name today. I can solve literal equations for the indicated variable. Justy gave us the definition for literal equation yesterday, so she can't give it again today. One of you other 8 have to give it. What's the definition of a literal equation? What's that mean? Julia?
There's one or more variables in it.
There's actually more than one. Yeah, so if there's just one variable, and we don't call it a literal equation, but once there's more than one variable in an equation, 2, 3, 4, 10, however many there are, when there's more than one variable in the equation, it's now become what we call a literal equation. Okay, so we're going to continue on with solving literal equations today for the indicated variable. So sometimes there's a fraction involved in our literal equation, in our formula. Remember we said that oftentimes a literal equation, another name for it is it's a formula for something. So when there's a fraction in the formula, first multiply both sides by the reciprocal of that fraction. We did this when we were solving one-step, one-variable equations. We had the variable being multiplied by a fraction. To undo that multiplying by a fraction, we would multiply by its reciprocal. So we're going to do that today. So we have our number 1 here, solve capital V equals 1/3 little l, little w, little h. They want us to solve it for h. What's it solve for right now? V. Solve for V right now. V is by itself. They want us to get h by itself. Okay, does anybody know what this is the formula for? What would we find with this formula? All right, Cody?
The volume of a prism.
The volume of a prism or a cylinder? No, but I will give you that it's volume, and I will give you that it's something that's three-dimensional. 1/3. That's the key part right there.
It's
The volume of a
pyramid.
pyramid. It's the volume formula for a pyramid. Because a pyramid comes to a point, to a peak. It's not a full prism. That's where the 1/3 comes in. Okay. So we have volume equals 1/3 times the what's little l? Length, w, width, and h, height. Okay. So to get first thing we're going to do is we're going to deal with the fact that there's that fraction in there that's being multiplied by. So we're going to multiply both sides of this equation by the reciprocal of 1/3. What's the reciprocal of 1/3? 3/1. So we're going to take 3/1 times the v side. We're going to take 3/1 times the 1/3 L, W, H side. So we're just introducing another factor on the right side to get rid of the 1/3. But if we do it on that side, we have to do it on the other side also. Okay. Now, we can make volume into a fraction also by putting it over 1. Because what do we do when we multiply fractions? We multiply across the top and across the bottom. So, what's the left side become? What's the left side of our equation become? 3b. Do we have to keep it over the 1?
No.
No, because something divided by 1 is just itself anyway. So we can ditch that 1, those 1s that would be downstairs. What happens on the right side when we do this? Okay, so these 3's cancel each other out, right? And these 1's cancel each other out. And we really have a 1, because when everything cancels out, we have a 1. So we have a 1 LWH. Do we need that 1 there?
No.
No, we can just write it LWH. Okay, that was the first thing you want to do is you want to get rid of that fraction. Okay? Okay, now this should look like something yesterday. What do you think we got to do next to get H alone? Divide both sides by LW, because H is being multiplied by LW. So to undo multiplying, we can divide. So we're going to write it again. We're not going to do it in that same step because otherwise, especially in these, it gets really confusing what you were doing. So write it again. I'm not letting you shortcut your division this time. So write it again, show fraction bars for division. We're dividing by LW. And hopefully if we did the right thing, H should be by itself. These L's will cancel, these W's will cancel, and sure enough, H will be by itself. How about that other side? Is there anything we can cancel on that other side? No. So we're just going to have to leave it looking like that. 3V, and that's a capital V. Remember, keep letters that are, this is really important in literal equations, so hear me on this. When letters are capitalized, leave them capitalized. When letters are lowercase small, leave them small. Don't change their case. Uppercase don't become lowercase just because you'd rather make lowercase letters. Or lowercase don't become uppercase because you'd rather make uppercase letters. You want to make sure you keep them what they were. And so the L and the W and the H are all lowercase and the V is uppercase. Really important because sometimes they'll use the same letter twice in a literal equation. They'll have a capital C and they'll have a small c and they both mean different things. So we got to keep them that way. So here's our final answer. It's not a value, right? It's just a new name for our equation V equals 1/3 LWH. So anybody have questions on that one? And this is what we do when there's multiplication by a fraction. Multiplication by a fraction. This is how we started. Okay, then let's move on to, I say sometimes you may need to undo addition or subtraction first. So we didn't have any addition or subtraction in that last one, so we didn't have to worry about undoing it. But if there is addition or subtraction in the problem, sometimes you want to take care of that first and then undo the multiplication. And typically it'll be multiplication that you'll be undoing, but we could say multiplication or division. Let's just put that underneath, just in case there is. Okay? So just like when we were solving multi-step equations that only had one variable in them, such as, let me give you an example over here on this whiteboard. If we have this equation, 12 equals 3x plus 4, what would we do first in that equation to start solving it? Abby? Subtract 4. We'd undo that addition first, wouldn't we? And then we would go back and undo the multiplication. So this is no different. It's just that this has a bunch of variables in it and not numbers, okay? So we're going to solve y equals mx plus b for x. Coming up in chapter 4, we're going to be using this form, this equation a lot. It's called slope-intercept form for a linear equation. So we're going to use this a lot. But right now what we're going to do is we're going to take this and we're going to get x by itself. What's it solve for right now? Y. It's solve for y. We need it solve for x. So what do you think our first move should be? Noah, what do you think we should do?
Take mx divided by mx on both sides.
Think of this equation, what we just talked about over here. What do we say would be the first thing we would do here?
Subtract 4.
Subtract 4. So what? Let's keep that train of thought. What do you think we should do? Subtract b. Yeah, let's get that b out of there. Undo the addition or subtraction first. So we'll subtract b from both sides. And it might be a good idea to do something like this to help you keep it straight. Okay, you're taking a b away from both sides. When we add or subtract, we just do it once on each side. Okay, so now we have on the left side, y take away b. Some of us think that that's yb. What does yb mean? Y times b. Is this y times b? No, this is y subtract b. So then we have to ask ourselves, are they like terms? Are y and b like terms? No, they're different variables. They're different variables. So all we can do is write it like this. We're going to write it y minus b. We're going to write it horizontally. Equals, what's left on the right side? Mx. Okay. What would be our next move in this one? We need the x alone. Devontae? What should we do next?
Get rid of the M.
Okay, get rid of the M. Say, see ya.
Divide by
Good.
M.
Divide both sides by M. Yeah, okay, so divide both sides by M. Remember, we're not going to shortcut this. We're going to write this again. Y minus B is going to get divided by M. We're not shortcutting this. I'm making you write it again. No options here. Equals mx divided by m. And notice what I did. I made a great big long fraction bar. You can't just divide one of the pieces by m. You've got to divide the whole side by m. The only other option you have, I'm going to go over here and I'm going to show you. If you don't want to do a big division, one big fraction bar, you can divide each piece by m. But then that's how it would have to look. Okay? Here we don't say each piece because this is a piece. Multiplication, those guys are stuck together. They are a piece together. Y is its own separate piece. B is its own separate piece. So you could write it like this, but typically this is actually easier to do it like this. Okay? So can we do anything there? Y minus B divided by m. Is there any canceling or anything we could do? No. If we look at it over here in this form, y divided by m, there's no canceling. B divided by m, there's no canceling. So we're just going to leave it as y, take away b, over m, complete fraction bar, equals, any canceling we can do on the right side?
Yes, and
What? The m's, okay, and so we have x. Solve y equals mx plus b for s. Do we have it solved for x? Okay, then we're done. Not pretty, but done. So any questions on that? Okay, now let's go to the back and see what we have to do back there. Okay. Oh my goodness, what do you think? Number 3, solve m equals t minus r for t. Josie? If we added r to both sides, t would be by itself right away, wouldn't it? Add r. So one's on each side. Is m plus r mr? No, what is it? M plus r. They can't be put together. They're not like terms. And these guys, that undid the subtracting r, add r undoes each other. We have t by itself. Presto, that one's done. Painless. That one wasn't too bad. Don't know what that's the formula for, or if it is. Okay, chances are it is, but I don't know for what. Anybody in here do know what m equals t take away r is? No? Haven't learned anything in science that would help us with that. Do you see formulas in science? Do you see literal equations in science class? Have you seen any yet? Can you name any? Anybody know any? I'll take that, Devontae.
Oh, shut them off.
Oh, well, it should have been shut off before class. I can't, I'm not going to believe that. So bring it on up and put it on my desk, thanks. Golly. Okay, let's do number 4. 2a plus 2b equals c. We're supposed to solve it for b. How are we going to get a b out of there? Anybody have a suggestion how we could start, maybe? Josie?
Subtract 2 on both sides.
Yeah, so in other words, it's the b's we want alone, so don't worry about the fact that there's 2 of them right now. Just say, you know what, b's, I want you alone. So 2a is being added to you, so I'm going to subtract 2a. That's where I'll start. So we'll subtract 2a from both sides. Get that out of there. Well, what do we have now on the left side after we subtract that 2a? 2b equals, and what do we have on the right side?
C minus 2.
C minus 2A. Can't put them together, they're not like terms. C's are not like A's. Okay. Suggestion what we would do next. Aurora, can you give us a suggestion? Even if you're like afraid it's wrong, it's okay.
Divide both sides by 2.
Yeah, divide both sides by 2 because, Calvin, why should we divide both sides by 2?
Then they're both just B.
Then we'd have that b up just by itself because b is being multiplied by 2. So we write it down again. 2b divided by 2. C take away 2a divided by 2, the whole thing. And then we say, on the left side, what happens? It's B. Okay, B because, why is it B? Tori, why does the left side become B? 2's cancel out, thank you. So B's by itself. How about the right side? What does the right side become? Cody?
C minus A.
So that's a really easy thing to think can happen. And most of us do think that can happen. Because these 2's that are here look like, you know what, they can cancel out, can't they? But here's the deal. The reason that they can't cancel out is because it's not C, it isn't C times 2A. It's not a multiplication chunk. It's 2 pieces, and remember each piece has to be divided by 2. So we can't cancel like that. So we have 2 options here, okay? I'm going to show you the first option is we're just going to leave it like it is. We're going to say that's as good as it gets, okay? So write that one down. But I also want you to see, because just in case in an answer bank it doesn't, you're like, this is the answer I got. It doesn't look like anything in the answer bank. So stay with me here. This is important. Because Cody made a really valid attempt at thinking we could cross those 2's out, and lots of us think we can. Lots of people think they can. Even people who think they're, like good in math. And we can't because I'll show you what actually happens, okay? In this, no, that isn't where I want to do that. I want to, up here in this step, I want you to put an arrow, and I want you to put that there was another way we could have shown this step of work. We divide every piece by 2. Give each piece a divided by 2. Okay, I want you to do this. Because now, within each piece, we can decide if we can do some canceling. So we can still cancel those 2's in this one. We have a B. Is there anything to cancel in C over 2? No, so we have to leave it C over 2. C divided by 2. Bring down our subtraction sign. 2A, that's a multiplication. Can these 2's cancel? Yes, they can. And what do we have? A. So this is really the same thing as that, just gone about it differently, as they might say, try to simplify it. So you might possibly see the answer in the answer bank the second way rather than the first way. I'm going to take either way as long as you've done it correctly. Okay? Questions? Okay.